x to the third plus 2x, and y of 0 equals -7. So this is dy over dx equals 2x cubed plus 2x. Of course, we multiply by dx. So dy equals 2x cubed plus 2x dx. And we integrate now, and we get, I meant to write y. So y equals 2x to the fourth 2x to the fourth over 4 plus 2x squared over 2 plus a constant c. When x is 0, of course I'll simplify in a moment. When x is 0, y is -7, so c equals -7. So y equals x to the fourth over 2 plus x squared minus 7. Then we're given a differential equation, the second derivative minus 1 over x equals 0. And we're given a function, we did this in class together. And we're asked, is this a solution or not? Do we need to work on this problem?
Yes, please.
Very good. So we have to find y prime. This is a product rule. The first function prime times the second one plus the first times the second prime. So this is natural of x plus 4. Then we have to differentiate again because the equation does not have, the differential equation does not have y prime in it. So when we differentiate again, we just get 1 over x. And of course, when we plug it in, the answer is yes. Any questions on this?
I was wondering how many questions we're supposed to expect for exam 3.
I think it's about 16 questions, and one of them is extra credit. The one that is awarded 1 point. Of course, I'm going to add 9 to it.
Okay, thank you.
Thank you. We're given a function with 3 variables, and we're asked to evaluate it for 0, 1, and 3. Yes or no? You just have to plug it in and calculate. There is nothing to it. So f of x comma y comma z, xyz minus 2xy plus 3 to the x plus 22yz. We're asked to find this. Any term that has x in it is a polynomial, will be 0, but 3 to 0 is 1, and then plus 22 times 1 times 3. So 67. That's all we need to evaluate. So if we have time, and I think we will, we can repeat the d-test if you want on this one. But I'd like to look at the last 2 problems, and then we can come back to anything else. Any questions on this? Okay, I selected problems 13 and 33. One from 583, the other one from 536. So let's take a look. Let's start with 536. I just wanted to make sure that we went through all problems. And now we can go back and do more and choose more, etc., etc. So I chose 13. 13? Really? Oh, no, 33. Sorry. Okay, so we have 33. So this is problem 33 on 536. 3y squared dy over dx equals 5x. So here we have to separate the variables, so we have to divide both sides, multiply both sides by dx. So 3y squared dy equals 5x dx. This is quite simple. So we have 3y to the third over 3 equals 5x squared over 2 plus a constant c. The only thing we need to do is take the cube root from both sides. So then y equals the cube root of 5/2 x squared plus a constant c. So we solved the differential equation, and the last problem is 13 on 583, which is a linear regression situation. Let's see if we have any questions on this problem.
For this one, the reason there's only a constant on one side is you can like combine them, right?
Yes. So if you remember, we said, I know that each integral has to have a constant, but if you write a C1 here and a C2 here, when you move C1 to the other side, you get a C. Very good. Other questions here? Okay. And the last one was the linear regression problem, which was on page 583. And I selected 13. So this one is only with the calculator. I'm not asking you to do anything by hand. So the 13, let me copy 13. So we have the table. So 13 on 583, we have 0, 1, 2, 3, and 4. And we have 1.4, 1.69, 1.91, 2.14, and 2.34. And they want us to predict in 2022, and we know that 2012 is t equals 0. I'm sorry, x, same thing, time, okay? And what year will be the number first exceed 4 billion? And y equals 4 billion. Okay, very good. So we put this in the graphing calculator, and we find something called the predicted value, y hat. So let's do that. So within y equals, no, that's not what I meant to do. Stats, sorry, edit, clear the lists. Let me clear, and let's clear. Okay, so we have 0, 1, 2, 3, 4. 0, 1, 2, 3, 4, and 1.4, and then 1.69, and 1.91, and 2.14, and finally 2.34. Good. What I'd like to do is, first of all, see the viewing window 0 to 4 for x, and 0 to 5 for y will be good enough. So I'll go to window. First, let's go to second and table set, because I want to turn on this plot, scatter plot. I just want to see the data. Okay, so I'll go to window, and I'll change the viewing window from 0 to 8. That's not what I meant. From 0 to 8 with a scale of 1, that's fine. And 0 to 8 again. That's not what I meant. 0 to 8. I just want to see the points. Yeah, nice. Looks like linear. Very nice, with a positive slope. So now I go to stats and calculations, and I choose number 4. This was all recorded in case you forgot. I want the calculator to store the equation for me. I don't want to type it in myself. And I'll go to variables, y variable, and in function y1. And now I calculate. And I will copy exactly what I see here. 0.233x and plus 1.43. And this should be already in the graphing calculator. Here it is. And when I click on graph, very nice. Very good prediction. They want us to determine what happens in 2022, which is 10 years later. With second and table, I will just simply plug in 10. So it's 3.76. So y hat for 2022 is 3.76. Now, the last part is totally different. But we have to look and see at the measurement unit. Okay, so everything is in billions. So I don't have to, I just have to set it equal to 4. So I have this equation, and I have to set it equal to 4, because everything is in billions. So 4 equals 0.233x plus 1.43. I subtract and divide. So then x equals 4 minus 1.43 over 0.233. And this is the x, number of years since 2012 when y will reach 4 billion. This is just solving a linear equation. Don't forget parentheses. 4 minus 1.43. Close and divide by 0.233. So it will be 11 years. 11 years since 2012. So it's going to be 11 years, which means when I add 11 to 2012, it's going to be 2023. Okay, so now you tell me what you would like to go back to. We still have 15 minutes, plenty of time to go back. If you want to calculate anything, if you want to find, this problem was we were given the revenue and the cost, and we were asked to find the max of the profit function. So that was the other one.
Can we do the d-test on that one?
Yes,
Find it.
yes. So let's look at the d-test. Are you okay with all the others that we did not finish because we did not put them in the calculator? Are you okay with all the other ones? These two we did not finish. Are you okay with these two? Okay. Here we did not finish because we did not put those in the calculator. Is this okay? Okay, this one we did not finish because we didn't put in the calculator. I think,
Professor,
say it again.
I was wondering the video for the how to put the integral into the
Look at
calculator
the
is still-
top module. Look at the top module and see if it's there.
Okay, thank you.
Let me know if it's not, please. But I remember I put it in and it's labeled correctly. But who knows? It's better to check now.
Yeah, I see it in there. Thank you.
Thank you. Okay, so good. So here we were given a revenue function, 18x plus 25y, and a cost function. I didn't mean to put a, I don't want you to get confused here. It's just a comma. Good. And the cost function is 4x squared minus 6xy plus 3y squared plus 20x plus 19y and minus 12. Good, so first of all, we have to create the profit function. We don't have the profit function. They're giving us the revenue, they're giving us the cost, but they're not giving us the profit. And we know that this is the revenue minus the total cost. Please remember to subtract everything from the cost function. So 18x plus 25y minus 4x squared plus 6xy minus 3y squared minus 20x minus 19 and plus 12. Again, minus and then plus and then minus and then minus and then minus and then plus. So now I'm going to try to clean it up as much as I can because I can combine these two, nothing else. So negative 4x squared plus 6xy minus 3y squared. And now minus 2x and then plus 6y and plus 12. This is the function we have to work with. And we have to find 6 partial derivatives. Px, py, pxx, pxy, pyy, and pyx. Okay, so first I have to find px. Px, negative 8x plus 6y minus 2. Negative 8x plus 6y minus 2. Py, 6x minus 6y plus 6. Pxx, nice, negative 8. Pxy, nice, negative 6. Positive 6, sorry. So pxx, negative 8. Pxy, 6. Pyy is negative 6. And pyx, py with respect to x is 6. These have to be the same. Please remember that. If they're not the same, something is wrong. Pyx and pxy have to be the same. Okay, now we are ready for the d-test. For the system and then the d-test. So we have px equals 0 and py equals 0. Negative 8x plus 6y minus 2 equals 0. 6x minus 6y plus 6 equals 0. This is our next step. We have to find the points, the critical points, by solving the system. So, negative 8x plus 6y equals 2, and 6x minus 6y equals negative 6. I moved negative to the other side. It became positive. I moved 6 to the other side. It became negative. Wonderful. I'm using elimination method. Negative 2x equals negative 4. So x is 2. I have to find y. I go back to any equation, it doesn't matter. Well, let's say we go back here. It doesn't matter. So I can simplify first of all by 6. So I have x minus y plus 1 equals 0. And then I replace x by 2. So a negative y equals negative 3, so y equals 3. So I found the critical point. Now I'm ready for the d-test. Pxx is negative 8. I cannot plug in anything, it's just negative 8. Pyy is negative 6. There is nothing I can plug in. I should have plugged in 2, 3, but there is nothing. Minus pxy or yx doesn't matter, squared. Very good. So 48 minus 36, I don't even care for the number. It's a positive number. And pxx is negative. So that means when d is positive and pxx is negative, it means that 2, 3 gives a relative max. But what is it? I don't know. I have to go back to the profit, carefully plug in 2 for x and 3 for y, and I'll get the actual maximum.